Hi, in this session we shall see about the NFS and TFTP protocols, a brief overview about Network File System Protocol and trivial file transfer protocols, and the respective configurations on U-Bootloader and development PC as well. Here we have some brief information about the Network File System Protocols. Network File System Protocol is an distributed file system protocol developed by Sun Microsystems, which provides something like a very flexibility to mount the disk and directories present over the network. And it's something like we can mount some of the directories present in the other network PC in our PC. That can be mounted. The similar way, the disk which is present inside the another PC, which is it can be a LAN or WAN, that we can able to mount it into our local PC here, and which provides something like a mechanism which the NFS server should exports that particular directories, and whichever directories are exported by the NFS kernel can be mounted through the remote Linux systems, and which basically used to share the data in a centralized manner with the server and the clients. The client, whatever the client modified data will be visible over the server, and if there is a data changes in the server, that it will be get reflected on the client mounted locations, which provides something like a data sharing at a easier manner. And here we use that NFS server directory as a embedded Linux root file system itself, so that the data directory of root file system which will be present on the development PC, the embedded Linux hardware will mount that the particular directory as its own root file system directory, so that the data can be shared between the board and the development PC becomes very less. So becomes something like we no need to copy that into SD card and boot it again, those kind of issues. Whatever the changes we are doing on the development PC will get reflected on the Linux root file systems, and we can directly run. For example, you are building some application. Once it got built, you can copy the binaries and you can run directly over here. You no need to reboot your Linux hardware. That we will see, and how we can set up that NFS over here. And it also provides something like the changes and modifications, whatever be the changes done over the client by the client as well as the development PC, which gets visible immediately due to that NFS is shared directory has been used by both embedded Linux hardware and then development PC basically. And the next one, we will be having something like kind of a TFTP protocols. TFTP protocol which will be used to transferring the files, that is simpler than the FTP, which is something like a lightweight FTP which can be used in case of you does not need any user authentication, does not need any directory to be discovered and directory to be visible to the client. That in that cases it can be used as the TFTP, and TFTP is lightweight and it uses that user datagram protocol instead of the TCP, and the main primary usage of TFTP at the initial stage is to boot from local area networks. Here also we are trying to boot the Linux kernel and device tree images over the network, basically, that we will be seeing over here. And the development setup environment will be something like here, and we have the USB to TTL cable that it has been connected over the serial port connector over here of the beaglebone black, and we are going to connect this to the development PC that will be get enumerated like a TTY USB 0, and we have that Ethernet cable connected with the beaglebone black, and the other end I'm going to connect it with the development PC, basically, that we will be seeing over here. I'm going to connect my USB to serial TTL cable to my PC, development PC. I got connected. Maybe I will open it. I'm going to do sudo minicom. This opens something like a minicom shell over here, and I'm going to connect other end of the Ethernet cable to my other PC over here. Yes. Now I am going to power up the board, and during the power up I am going to press this S2 button so that it will get boot up from the micro SD card, basically. Yeah, I just pressed over here, and I am going to connect the USB cable to power on. Sorry, there is an issue. I think there is no cord present. Yeah. I'm just plugging the cord over here, and I'm going to press this S2 button, and I'm going to connect power on the board. Yeah, it's booting. Maybe I'm going to stop it over the U-Boot in order to configure. Yes, we just stopped over here, and we need to configure that the both end at the development PC as well as over here in order to get establish the communications over. And in order to do that, maybe we have some of the commands of the U-Boot environment to be configured. In order to load, we have to first configure that the IP address and then server IP over here, and I'm going to configure set I just stopped over here, and I'm going to do set env IP address on 92.168.3.3 and set env server IP on 92.168.3.1 and set env netmask 255.255.255.0, and I'm going to save this over here into these partitions, and I'm going to configure this one my development PC to shrink this. Yeah, if config, I have that Ethernet. I'm going to configure if config, and this one 192.168.3.1, and I'm going to make it up. Okay, it has to be sudo, and yeah, now we can check whether our connection is perfect or not by pinging from the board, and we cannot ping the board while we are in the U-Boot. We can only ping the development PC from the board 192.168.3.1. that we can check over here. It becomes 100 full duplex, and it's not pinging, and I'm going to check it over here. It was now only it has configured over here. Now we got something like a 3.1 is alive now. Now we got that alive message from over here, and I'm going to do something like this. We wanted to make that TFTP images should be boot from the TFTP server. Maybe we have the TFTP over here, and I'm going to do something like a mk cds. This is the location we have that the TFTP server is running, and we can able to fetch that images from over here to the board. That it can be done by using the command called tftp over here. The tftp, then load address. Basically this we are moving that zImage to the RAM location which is defined in the load address, that we can be able to give it here. Now it's loading that the zImage from the development PC to here, and it's loaded that loaded that zImage file into the memory. Load address 82 followed by 6 zeros. The similar way we can do that the booting, the device tree can be loaded into this load address, that is FDT address, the file that we are loading over here, and it got transferred. Now we used that TFTP to load zImage into the DRAM location 82 followed by 6 zeros, and we used that device tree get loaded into the address location of 88 followed by 6 zeros over here. Now we got that loaded that images, and we need to configure that boot arguments accordingly, so that will be get booted with that. Basically we can do for that, we can do something like in order to make this boot sequence to be common, maybe we can do the setenv of boot command, so that we no need to configure this at the every time. Maybe we can do that by pasting over here, and Control ASW. I'm going to do Yeah, I'm going to type setenv boot 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 command tftp boot dollar load addr, which we are going to download over to the load address, and we are going to download into fdt address that am335x, the dtb file directory file of um, am335x, and over here there is a type mistake, am335x hyphen bone black dot dtb, and then boot m dollar load addr hyphen dollar fdt addr. This makes that booting from the TFTP. I am going to save this over here. Save env. I just saved, and this makes that the system loads the images from the TFTP and is a kernel image and device tree images from the TFTP, and it boots that kernel image and with the device tree, and we are going to configure that bootargs so that it will mount that the root file system as the network root file systems. That we can able to do with the Uboot environment variable of setenv bootargs. For that we need 3 different types, something like console equal to tty, O0 and 115200. N8 is the baud rate and no parity and 8 data bits, and we will be having something like a root is the one with the dev NFS, and we have nfsroot, the exported directory that we have to give, and we have something like IP and board IP and gateway IP, and then network mask that we have to give over here. And we can check something like over here that we can copy this provides something over here. I can copy it's something different with respect to this. Maybe we can type it over here, setenv boot args I am going to copy partially and the NFS is we just added that the console equal to tty O0 115200 and baud rate no parity and 8-bit data bits, and root equal to dev /nfs, so that it will try to use that network file system, and nfs root directory is something like 3.1, which is an server IP address, and we will be having something like home neevee projects and BBB TI processor SDK, which is the location of over here that which we configured for the target rootfs, something like home neevee. Maybe we can confirm that by using this, and sorry, home neevee, and then projects, and then bbb, and then ti processor sdk over here, and maybe 06 and 06007 over here, and over here 007, and then hyphen Linux and SDK over Linux, and then targetNFS is the directory that we will be seeing over here. Maybe I can do that. Yeah, maybe I can do something like this. Maybe I have to edit over the text. Maybe I will open notepad, that will be easier. Easier to copy and paste, which will be little. I'm going to do Control C and then Control V over here, and dev slash 06, that the location is something like hyphen Linux hyphen x86. That was the location. Hyphen Linux hyphen x86 is the location of installation, and I'm going to copy this completely, and maybe I will be pasting over here so that this will be good. And shift function insert, yes, and we can confirm that whether the value got set properly. Print env bootargs, yeah, and there is a gap between over here, and maybe we can do bootargs, yeah, Control C and then function insert, yes. Now we can do something, print env bootargs. Now we got that information, and I'm going to save this over here. Now maybe we can do, if we do boot, and if we type the boot, then our boot command will get executed, and it loads that Linux kernel image, and then zImage, yes, sorry, and maybe we need to edit env boot command, and it has to be something kind of a set env boot command will be something over here, and the command will be to boot from the zImage. It should be something like bootz, and this should be fine to copy. And shift Z, Yeah. Now I am going to save env, save this environment variable, and I am going to boot it from over here. Boot. It boots. It loads that Linux kernel and it started booting the Linux kernel over here, and it should get mount the root file system and it start executing that the rootfs basically. Yes. After configuring the boot command and bootargs, it should something like print env boot command, which is something like loads that zImage into the 82 followed by 6 zeros location, and device tree file into the 88 followed by 6 zeros, and boot z the load address after that file device tree address that it has been added over here. And yeah, and we can check that the print or bootargs whether it was properly configured by using print env bootargs. It starts with that console equal to tty0 and 115200N8, which is something like a baud rate, no parity, and 8 data bits, and root is dev/nfs, which is something like a network file system, and that should be mounted like a read and write, and nfsroot is something like the server IP / the server exported directory, and we have the no lock. It will not be get any lock, and we have added with the IP address, and this is the baud address 3.3, and gateway address is 3.1, and we have that netmask will be 255 and 255.0. that was the netmask. This provides something like it loads that kernel images from TFTP into this location, and device tree into this location, and it starts booting from using those two downloaded, and we have the console, and whatever be the console logs, kernel bootup logs will come over the TTY00, which is an USB serial port, and it mounts that root file system, and it starts executes that user scripts and runtime scripts, and it has to get mounted. Maybe I am going to do over here by running the boot is the command which will starts something like executing the boot command, and we will be get now the Linux kernel got booted up, and now the Ethernet link got ready, and it mounted the root file systems over here. Maybe we can have a look over here, and we got something like over here that mounted the root, which is NFS file system. Maybe once it was continuously prints are coming, it was keep on growing. Maybe we shall check once the prints are complete and we got the Linux shell prompts. That yeah, we shall wait for some time, maybe 1 or 2 seconds. Yeah, now we got that the prompt over here, Linux kernel prompt, which basically mounts that Arago distributions root file system, which is present in the over development PC. That we can see over here. The Linux kernel got booted up. Linux kernel got loaded in the zImage got loaded into 82 followed by 6 zeros. After that, we got something like a DDB file got loaded into the 88 followed by 6 zeros, and then we are going to boot the zImage location, and which is 82 followed by 6 zeros and hyphen, and device tree location 88 followed by 6 zeros, and it starts the booting up on the Linux PC. And once the Linux kernel got booted up, and it will mount the root file system and it start executing the scripts. And we can able to see here that it basically that it got the enumerations of the IP address whichever we have given. The host IP address is 3.3 and the boot server is 3.1 and the NFS root server is also the 3.1, and it mounts that root file system, mounted the root file system over the NFS file systems over there, and it started executing that the scripts over here. Welcome to Arago, and it started executing all the different services, runtime services, and we got something over here that we got it over here. It mounts the root file systems, and maybe we can do something like here. Maybe I'm going to create some, maybe we can do cd home neevee, then projects bb, and then ti06 and target NFS over here. Maybe here, maybe I'm going to create a directory mkdir. Yeah, I'm going to make going up over here, since it was not visible, mkdir something like test over inside the target NFS, and maybe we can see over here, and I can going to do some sync, and then maybe here we can check with the sync. Then if we list, now we got the directory called test over here, and inside the test maybe I'm going to create something like a test vim hello world.c. sorry, there is a spelling mistake. Vim hello world.c, in that include stdio.h, and then integer main, integer argc, character star argv, and then I'm going to do printf hello embedded Linux over here, and I'm going to do return 0. And if suppose I'm going to compile this over here, maybe our GCCs will be present over here, something like dot 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 dot, and we will be having the GCC inside the Linux dev kit and sysrootfs, and then x86 Arago, and then user bin, and then we will be having something like om-linux-gcc is the location, and I'm going to do hello world, and then hello world.c. I'm going to compile this over here. Now I got compiled. Now if we check file hello world, which is something like it's compiled for ARM architecture, maybe I'm going over to the board, which is an minicom console. Maybe if suppose I'm going inside the test, there I can able to see hello world and hello world.c. Maybe I can execute the hello world, since it is compiled for ARM architecture, that I can able to compile over the beaglebone black. Now we got something like hello embedded Linux printout, so that whatever be the application development or kernel module development can be done easily and we can compile over the development PC and easily run it over the uh, embedded hardware in a faster manner. This makes our development at the faster pace. This session provides something like setting up the NFS server and TFTP server. If suppose you are into Linux kernel development and you are keep on changing the Linux kernel images or device tree images, at the time you no need to copy into the SD card or eMMC to boot it every time. Instead of that, you can download it through a TFTP and you can get it booted from the boot the beaglebone black using the downloaded kernel and device tree images and mounts with the root file system over the NFS. Yeah. Thank you. Happy embedded Linux. Move forward with the porting or Linux device driver development over the upcoming sessions. Thank you.